Welcome to the 8th session of Business Statistics Part 2. In the present session, we'll be discussing about Karl Pearson's correlation coefficient based on the assumed mean method and also the calculation of probable error. This problem is a little different problem compared to the other problem. So let us see the calculation and the steps to follow to calculate the correlation. The following table gives the distribution of items of production and also the relatively defective items among them according to the size groups. Find the correlation coefficient between the size and the defect in quality and find its probable error, and also comment on the results. So in the present problem, you are given the size group, number of items and the number of defective items. So now you have to concentrate on the question that what correlation you need. So look into the problem. We need the correlation coefficient between the size group. So the first row of the problem, that is size group, has to be considered for the calculation of problem. And defect in quality. So to calculate the defect in quality, you have two rows here. One is number of items and number of defective items. So that means that among 200 items which is produced, 150 are defective in nature here. So you have to calculate the percentage as to what percentage of defective items are present in the given size group. So then you can arrive at the calculation of correlation coefficient. So now before going to the calculation of correlation, let us see how we can calculate the percentage of defective item. In the above problem, we need to find the relationship between the size group and the defect in quality. The size group is already given in the problem, but the percentage of defective items based on the number of items which is produced has to be computed. So we can use this formula and we can calculate the percentage of defective items. So number of defective items divided by number of items into 100. So the calculation goes in this way, that is among 150 items, among 200 items, 150 items are defective. That is 150 divided by 200 into 100. That will give us the percentage of defective item in the given size group. So the same pattern calculation has to be followed for the different size group columns, and we will be arriving at the percentage of defective items of all the size groups. So now these percentage defective items will be considered as one of the variable for the calculation of correlation. Now let us assume this size group as the x variable and percentage of defective items as the y variable. And as we are using the assumed mean method here, we have to assume one value for x and y as the assumed mean to calculate the deviations. So let us assume the mean of x as 18.5 and y as 50. So now you can have a question that why 18.5 is the assumed mean. So as the size group is in the continuous series, to continue the calculation we need the value of x, and x of a particular continuous series will always be the mid values of the series. So we have to first consider the mid values of the series and then continue with the calculation of correlation. And you can assume any of the midpoint as the assumed mean of a particular series. Okay. So now x values, that is midpoints, are calculated, and you always you know that the midpoints are calculated in this way, that is 15 to 16 is given, right? So 15 plus 16 divided by 2 will give us the midpoint of that particular class interval. So the next calculation, that is dx and dx square, we have already discussed these calculation in the previous sessions also. That is, x minus assumed mean will give us the deviation of that particular row. So 15.5 sorry 15.5 minus 18.5 will give us the value of dx value. Okay, so in the same way we have to calculate all those dx values and obtain sigma dx. And then for the calculation of next column we have to square the dx values and we will obtain sigma dx square. The same step has to be applied for y values, that is y minus y bar, that is y bar here refers to 50, and in the next column squaring the dy values, and the last column that is multiplying the dx values to the corresponding rows of dy values, and we will obtain sigma dx into dy. So all these steps are as same as the previous session problems, and now we have to apply all these values into the formula. So when all those values are substituted in the formula and solved in a particular mathematical step, we will arrive at the value of r, and here r is equal to 0.949. This is almost equal to 1, where we can say that it is a perfect positive correlation. So we will discuss about the analysis in the next slide. Now we should also calculate the probable error of this problem. So probable error is equal to 0.6745 into 1 minus r square divided by root of n. So that is, when we substitute the values to this formula, we will get the probable error, that is 0.0273. So now let us look into the interpretation of correlation. As I said, as it is 0.9, it is almost equal to the positive correlation, but as we have not obtained +1, we can say that it is a high degree of positive correlation. Now let us look into the analysis part. The correlation coefficient of x and y is 0.949. So we can say that there is a high level of positive correlation between the size group of the production and the percentage of defective items which is produced. The probable error that could occur could be 0.0273. So now we have to calculate the limits of this correlation coefficient by adding and subtracting the value of probable error from the value of r. That is, r plus probable error will give us 0.9763, and r minus probable error, that will give us 0.9217. So the value of r has to lie between these two values to become a significant value of correlation.